Right, thanks. Hi everyone, my name is Tommy. I'm an open source developer under the Code Day teams. And right now my main focus is on the Kubeflow project. And in today's session, I'm going to go over the high level view of the Kubeflow repository. So Kubeflow is a open source community-driven project to help make like ML stack on Kubernetes very easy. And under like the github.kubeflow, github.com/kubeflow, you will see a lot of repository. Some of them are like related to the main components, but some of them are related to like documentation, testing, and like common packages, etc. So I will go over like on a high level view what each repository is. Um, so usually in a client machine, you will have some ML tools. In this case, it would be like some machine learning frameworks like Trainer, PyTorch, TensorFlow, MPI, those kind of packages for your clients. And then inside like the Kubeflow application stack, you will see each of those clients could be used for like different operators for doing distributed training. So if you look at under the left side of the Kubeflow application, you will see a list of operators and Jupyter Notebook. And those are like all meant for doing distributed training using like the Kubernetes CRD. And then on the right side of the blue circle, you will see a list of major components inside Kubeflow, like knative, fairing, metadata, pipeline, Kubeflow UI, KF serving, and TensorFlow batch predictions. And behind the scene, we have it also have like third-party applications such as like Istio, Argo, Prometheus to help us enhance the experience and connect things together. And behind the scenes, everything is running on Kubernetes, and you could like deploy Kubernetes on different cloud provider or on your on-prem machines. So now let's go ahead and introduce what each repository is. So on a very high levels, the first repository you probably see is the Kubeflow. That is like the main repository for the Kubeflow. And there's some history back then, like when they started, everything is in this single repository. But nowadays, it only remains like the central dashboard, Jupyter web apps, and notebook controller, and some of the testing related stuff. Most of the stuff is already being moved outside of this repository. And then the next repository is the website, which is mainly for hosting documentations. And it's also the source code for the kubeflow.org. So when you go to kubeflow.org, you will see like all the documentation related to Kubeflow and how they construct the website. And all the source code for this is under like this website repository. And when you go to the website repository, the first thing you could see is the quick start, where you could just start very quickly to experiment how you could update the website and do a pull request based on that. And now the next repository is the community. This is mostly contain like information related to Kubeflow community and how they organize all the calls. And then the next one is the examples repository, where it contains all the end-to-end examples and some of the conference demo you might see. So under the example repository, you probably see a table of content of like different end-to-end examples where you could just click and try out. And then the next repository is the code intelligence. This is mostly contain code for like the Kubeflow bots and and also like the label bots you might see when you create a pull request or issues. And then the next one is the manifest, which is one of the major ones in the Kubeflow organizations, where it contains all the installation code for the Kubeflow stack. So let's go ahead and see the manifest repository. So under the manifest repository, you probably see a bunch of like subdirectory where each of them represent a component inside the Kubeflow stack. And then one of the major things we want to look at is the what we call kfdev, where it contains like different version of the Kubeflow stack deployments using the kfctl. So let's take, for example, for IBM Cloud, we have like different version of the kfkernel underscore IBM for deploying Kubeflow. And then we also have like DAX version for multi-user deployment as well in here. So that's the high level view of the manifest. And the next repository is the kfkernel. And kfkernel is like CTL CLI for deploying Kubeflow. And you could see there's also like a Kubeflow operators inside this repository where you could use the operator framework to deploy Kubeflow for you, and you could see the instruction underneath as well. And the whole CLI is coded in Golang, so so if you want to like build anything on top of this repository, you probably have to set up Go and then play around with it. So the next set of repository we're going to introduce is the metadata, where it contains information for tracking and managing metadata. And right now it's also integrated as part of the Kubeflow pipeline. So you could also see any executions or models or data sets that get produced by Kubeflow pipeline to be stored in the metadata service. And here's the repository for metadata. Usually in the README, you will see how you could build and test. And from here, you could see how you could modify code and then create pull requests based on like this information. So the next repository is testing. This is mostly containing just the end-to-end and CI test infrastructure. So most of the time we don't really need to bother about this unless you have something is broken, and then you might want to like take a look at the testing and see anything related to the end-to-end test is useful in this case. And the common is just a set of common Golang library to be used by different Kubeflow projects. So some of the operator code, let's say like the tensor TF drop operators, is used some of the common library for constructing APIs. But it's kind of specific to a particular project. So so probably inside the project developer guide, you could probably see what kind of common library you need to pull from this repository. And then for the front end is the repository code for the Kubeflow front end. So this contains code to build the main dashboard for displaying the Kubeflow dashboard. And you can see the development guides and testing guides and build guides all underneath the main README as well. And then pipeline is another like major repository for creating the Kubeflow pipelines. And Kubeflow pipeline contains the reusable end-to-end ML workflow, both including the SDK, UI, and the backend API. So let's go ahead and take a look at this repository. So Kubeflow pipeline repository usually contains very complex directory structure. So first it has the backend where it contains all the APIs, metadata writers, and different kinds of microservice for, let's say, managing your workflows and visualize like any tensor boards that you have. And then other components is where all the sample Kubeflow pipeline component is hosted. So anything you want to reuse from the community will be listed over here. And then another important one is the front end directory, where it contains the front end code of the Kubeflow pipelines. And then the SDK, where it contains the Python DSL code for converting Python into a Argo or Tecton based YAML, and you could use that to deploy on Kubeflow pipelines. And all the development guides related to this you could find under the developer guide.md. It will show you like how to build images for different microservice that you have. And also you want to do with the Python, you also have like Python-based developments and unit testing under here as well. So the next repository is the KFP Tecton, which is like a project we're heavily working on, and it's very similar to the Kubeflow pipelines, except like we kind of modify the backend and the SDK to run on the Tecton backend engines. So under this repository, you will see the structure is very similar to Kubeflow pipelines, where you also have like the backend, front end components, and the SDK. The major difference is for the backend, front end, and SDK, we actually implement our own plugins to like run it on Tectons. So for example, you click on the SDK, you will find like very specific instruction for using the SDK on Tectons and all the prerequisites and how you could set up Tecton and the DSL for running the Tecton backend version of the Kubeflow pipelines. And then let's go to the next set of repository. So over here, you will see a list of operators like TF operator, MPI operators, MSNet operator, and PyTorch operators. Those operators are for doing distributed training based on either different framework or different protocols. So the TF operators is mostly for TensorFlow using their native functionalities. So for the TF operators, the most common one is using the parameter server, and you could see you will see there's like some high overview on like how you could use it under the user guide, and how you could contribute under the developer guide. And you could base on this to set up your Golang environment and create PR based on like the unit test that you need to run. And the MPI operators is similar to the TF operator, except it is meant for running on the MPI protocols. Same thing applies to MSNet and PyTorch. They are very specific just for MSNet framework and PyTorch framework. And then the next set of repository is the KTIP, where it contains the code for doing the hyperparameter tuning on Kubeflow. So if you take a look at KTIP, the main page, you probably will see how you could do different experiment on here, and they explain some of the concept under KTIP, like such as experiment, suggestion, and trial. And underneath, you could see a list of algorithms and how they work under captive. So for hyperparameter tuning, you have a simple random search and grid search, but you also have like more advanced feature like hyperband and bias optimization, those kind of stuff. And they also support like neural net architecture search, where it is focused on the reinforcement learning. And also they have a web UI where you could visualize the captive experiment. And underneath, you will see the installation guide, how you could get started with your development environments. And the next repository is the fairing, where it contains a Python SDK to build, train, or deploy ML models. Since like fairing is just a SDK, so you probably won't see it inside your Kubeflow cluster. So this SDK is mostly for building a container inside a Docker when you're running on Kubernetes. And you will probably see like the Kubeflow fairing documentation on more details on how to use it. And this repository is mostly coded in like Python, so you will need to set up a Python development environment instead of like Golang. And the common way to see how to use fairing is to visit the end-to-end MS examples. And there will be a notebook to introduce how you could run the fairing SDK over here. So now let's go to the next repository, is the KF serving, where it's hosting code for doing influencing either serverless or non-serverless, including other capability on Kubernetes. So you go to KF serving, you probably see very good introductions on how you could get started. And there will be a set of prerequisites. You need to install like Istio, Knative Serving, and Cert Manager to before you start developing KF Serving. And once you have those installed, then you could create a development KF Serving environments using the install YAMLs under the install directory. And usually in the development environment, you can disable the webhooks, so you could just deploy KF serving on any namespace. And then for the developer guys, you could go under the documentations, the dots over here. And there will be a developer guide show you how to set up your Golang environments. And all the examples is also under the dots on the samples page, where it will list like different use case of KF serving. And also like the README under the dots will show you the architecture on how KF serving is being used. So it will have like multiple endpoints either for default and canary, and you will have multiple components. Mainly is the predictor, but you also could add transformer behind the scenes and have explainer to trigger the predictor as well. And there's many more other repository on the Kubeflow. So I could just give you like a high level overview. But those other repository is mostly for maintaining, let's say like block or other like minor components where most of the time we don't need to like worry about it. And you have any like questions with the repository, you could first, let's say for the internal ACL, you could click on it and see what's inside the main README. If the main README doesn't explain enough information for development, that means like this repository is mostly for internal use or like for documentation use. So that's the high-level view of the Kubeflow organizations and the repository view. So do anyone have any question or any repository they want like to take a look at?
It seems not. So you can choose.
I mean, like the next session, we're going to talk about Kubeflow pipelines.
There is a question. Oh, sorry. There is a question in the chat. A couple of questions. I can read them to you. What does it mean?
It's related to TF serving. So for more details, we're going to explain in the TF serving sections happening, I think, 2 hours later.
Okay.
We have a session on cave serving, which will go into the details of, both the questions, right? Why is it serverless and what are transformers?
Right. I mean, it would be great. So you look at the schedule, maybe we'll cover like Knative, KF serving, and pipeline in the next 3 sessions. So if there's any other repository you might want to get a little bit more information, I could answer right now.
So there is a question about fairing from
Fairing.
Romero. Tommy.
All right. So for fairing, it's more for SDK for doing building and or training, but I think it's easier to like go over one of the examples. I would say we have an examples under the example repository where you take a look at the MNIST notebook. It will have like different notebook to work on different cloud provider because Fairing is kind of built like specific for different cloud provider backend. So for example, in IBM Cloud, we have a notebook for this as well. So the notebook will be the one with the mns.ipython mode notebook. So let's go ahead and open that. And we could skip like the basic setup stuff and go to the Fairing part where over here we'll use Fairing to actually build the container for us and set up the credentials. So under Fairing, you could use it to create some values. Let's say in this case, we create like a canonical image base to build our Docker image inside a running container in Kubernetes. So it's sort of like Docker built in Docker. And then once you have that set up, then you could use Fairing to help you to import some helper function for uploading stuff to Minio and push like any information you need after the image build to the Minio storage. So you could kind of think of like this would be a bunch of useful helper functions that help you build and deploy based on different cloud providers when you use it on a Jupyter notebook.
I think the core idea behind Fairing is, you have that one single SDK, right, which you can, if you're doing work locally on your laptop versus, you're targeting a cloud provider, you can essentially use the same SDK and just switch the backend, right? So the thing is that, for example, you're using Fairing SDK and running on top of AWS and you want to move to Azure or you want to move to IBM Cloud or any other cloud provider, right? Fairing gives you that one single consistent interface to be able to target different cloud backends, but using the same SDK to go through the Kubeflow functionalities.
I think we're also seeing like question for like seldom. So seldom, if you take a look at one of the slides I have is they are technically part of the third-party application in the Kubeflow stack. So they're not covered inside the Kubeflow organizations. They only use it as part of the integration for, in this case, will be the KF serving. But most of the time, we don't really use it until you have a particular feature that actually need their container or their controller.
I would probably maybe just on that topic of Selden, right? So I mean, there are a huge part of Kubeflow community, a large part of Kubeflow community uses Selden, right? Within IBM, our focus has been on KF serving, which is more of a multi-vendor approach. Selden is also contributing there. So Selden, IBM, Microsoft, AWS, NVIDIA, we are all collaborating around KF serving, but definitely for folks who are into the Selden ecosystem and just want to use Selden as is, it gets shipped as part of the Kubeflow install. It's developed outside of Kubeflow, but shipped, and you can get an install of Selden as part of your Kubeflow install. Yeah. Any more questions on any of the other repositories? Has fearing been tried at scale? My experience with SageMaker notebooks is that kernel keeps dying for intensive jobs. It's the pertinent problems of notebook kernels, right? And I think what's happening in general in the Jupyter community is, right, people are creating bigger and bigger Docker images, right, bundling heavy duty libraries. And that was also one of the primary reasons, right, why we moved from initially Kubeflow in its early days was shipping with Jupyter Hub. I think somewhere along that line, 5 to 6 months, because of all these issues where kernels are dying, and in general, the lack of a better integration with Kubernetes under the covers at that particular point in time, Kubeflow decided to go and design their own notebook controller, right? So that's what is used to run these, right? So Fairing, depending on where you are running for Fairing, if you are running Fairing as an SDK on a notebook which is spawned through Kubeflow notebooks, you definitely will get much better performance, right, as opposed to what you have been getting on Jupyter Hub, right? At least that was the case, right? I mean, unless Jupyter Hub has improved considerably in the past 6 months, we have seen that Kubeflow notebooks performs much better in terms of ensuring that the kernel is alive and healthy.
Okay, so is this the end of this session?
I believe so, yeah.
Yeah,
Okay.
that's the end of the session.
Okay,
Yeah, we
great.
could go into like the Kubeflow pipeline next. Yeah.
Okay, all right. So